Fundamental concepts of exponent rules. Definitions. A times A times A times A n times A multiply itself n times. We can write it as a shortcut as A to the power of n, also known as A to the exponent n. As I said, if we multiply A by itself n times, we can write it as A to the power of n. We generally write powers or exponents as A to the power of n, where A is called the base, n is called power or exponent. If the exponent is 2, we say A squared. If exponent is 3, we say A cubed. For example, 5 times 5 times 5 times 5 times 5 multiplied 5 times, we can write it as 5 to the power of 5. Negative 3 times negative 3 times negative 3 times negative 3 times negative 3 multiply itself 7 times, we can write it as bracket negative 3 to the power of 7, which we can then further simplify as negative 3 to the power of 7. Why negative 3? Because if the exponent is odd, negative sign multiply itself odd number of times, 7 times. 2 negatives will multiply to positive, another 2 negatives will multiply to positive, another 2 negatives will multiply to positive, and one remaining negative will stay negative. Okay. Similar rule applies for fractions and decimals as well. If I have 2 over 7, multiply itself 6 times, we will get 2 over 7 to the power of 6. Exponent rules. Assuming m and n are positive integers, the following rules apply. The first rule, known as multiplication or product rule, a to the power of m times a to the power of n equals a to the power of m times n, meaning that same bases are being multiplied, we add the exponents. For example, if I have 8 to the power of 3 times 8 to the power of 5, we can write it as 8 to the power of 3 plus 8 to the power of 3 plus 5, which will be then 8 to the power of 8. Okay. Another way to look at it is like this. If I multiply 8 itself 3 times, 8 times 8 times 8, and then 8 multiply itself 5 more times, 8 times 8 times 8 times 8 times 8, 5 times. In total, I am multiplying 8 itself by 8 times. That's how I got 8 there. Similarly, the second rule is of division. If we are dividing two numbers or two variables with the same base, then we subtract the exponents. A to the power of m divided by a to the power of n will be a to the power of m minus n, where we assume m is greater than n, meaning that exponent in the numerator is larger than the denominator. For example, 8 to the power of 9 divided by 8 to the power of 2, we will simplify to 8 to the power of 9 subtract 2, which will be 7. Okay. 9 subtract 2 in the exponent will give us 8 to the power of 7. Now, another way to look at this is, in the numerator, I have 8 multiply itself 9 times. In the denominator, I have 8 multiply itself 2 times. Cancel out 2 8s from the numerator with denominator. I will have 7 more 8s remaining in the numerator. Okay. Opposite way, what if denominator had a higher exponent? Like for example here, 8 to the power of 9 is in the denominator. Then we subtract our exponents in the denominator. So we write it like this. 1 over a to the power of n minus m. So in my example then, I will say it is same as 1 over I will say it will be 1 over 8 to the exponent 9 minus 2, giving us 1 over 8 to the exponent 7. Okay. That's rule number 3. Rule number 4, if we have one base and two exponents in the two exponents applied to it, we basically multiply the exponents. So we say a to the power of n times m. So in my example here, it will be 8 to the exponent 2 times 3, giving us 8 to the exponent 6. Notice here, some of us sometimes get tricked with rule number 1 and 4. One is two same bases being multiplied, we add the exponents. Rule number 4, one base, two exponents, then we multiply the exponents. Okay. Rule number 5 then, if two terms are being multiplied and then there is exponent outside the bracket, that exponent applies to both variables or both numbers inside the bracket. So a times b all to the power of n is a to the power of n times b to the power of n. So example here, it will be 8 to the power of 2, 8 squared basically, times 3 to the power of 2, 3 squared. Okay. Rule number 6, very similar to 5, if two terms or two variables are being divided and if there is exponent outside the bracket, the exponent applies to the numerator and as well as the denominator. In these cases, if you notice, the restriction is denominator cannot be 0, and same with this one, rule number 3. Here a cannot be 0. Okay. So applying that rule here, we will get 8 square divided by 3 square, because the square will apply to 8 and it will also apply to 3. So we will get 8 square divided by 3 square. Okay. Rule number 7 then, anything to the exponent 0 will always be 1. Okay. So if I have 5 to the exponent 0, it will simplify to 1. If I have 9 to the exponent 0, it will simplify to 1. However, you have to be careful with something like this. If I have, let's say, 9a to the exponent 0, the 0, it basically means 9 times a to the power of 0. So the 0 only applies to a, not to the 9. So the answer will be basically, for that one, it will be 9 times 1, giving us 9, not 1. Okay. However, if I had 9a in the bracket and then exponent 0, if I have something in the bracket, outside the bracket exponent 0 is applied, the result will be 1. Okay. Last rule, any base to the exponent negative number, a to the exponent negative, if I want to get rid of a negative exponent, we write it as 1 over a to the power of n, where again a cannot be 0. So for example, a to the power of negative 2 will be 8 to the power of negative 2 will be 1 over 8 square. Okay. When raising a negative power or when raising a negative number to an odd power, the answer is negative. For example, negative 4 cubed will be negative 64. Negative 2 to the power of 5 will be negative 32. So the exponent here is odd numbers like 3, 5. The result turns out to be negative numbers. However, when we raise a negative number to an even power, when the base is negative and the power is even, the answer will be positive. Negative 4 square is negative 4 times negative 4, giving us positive 16. And then negative 4 to the power of 4 will be 256. Both answers are positive.